Good morning, everybody, and welcome to another webinar here with myself, Karen McKenzie. And today we're going to be looking at the simulation environment inside of Inventor. I'm using Inventor Professional 2023, but the features that I'm going to be showing you today are and have been available inside of Inventor for a while. So if you do have a slightly older version of Inventor, you'll be able to use these inside of your respective version. So yeah, today we're going to be looking at some of the simulations that we can come in and the simulation studies that we can run through our Inventor software. And as you can see on screen at the moment, I've got a brake pedal assembly over here. And essentially what I want to do is make sure that the brake pedal I've created will be able to withstand certain forces inside of a real world situation. So I've got my brake pedal here. And I've got it constrained in its manner so that as it pushes, as you push down on the brake pedal, it goes into the, it actually goes and presses through the cylinder to be able to create force for the brake pads as a brake would do so. So as I push down on my brake pedal, the movement itself happens inside of the cylinder itself. And in today's study, we want to make sure that the pin that we've got that connects our brake pedal and the push rod is able to withstand. So either the pin where it makes connection to the brake pedal itself and the brake pedal as a whole is able to withstand the force that we're going to be applying to this. Looking at it, the pin itself does look a little small, and we want to make sure that we've got the right thickness to be able to withstand certain forces inside of a real world situation. So essentially what we're going to do is we're going to take this brake pedal as a whole. You can see the pin itself is included inside of that part. And we've got our brake pedal here that's available inside of our assembly in our model browser. We can right click and open this particular component, this particular part, which will then begin to allow us to create a study for that particular component inside. I already have it open. You can see my tabs down at the bottom. I've got my brake pedal open and available to me at the moment. So I'm just going to open this up, and you can see it's the exact same one that's inside of the assembly. Essentially, from here, what we're going to do is just start to create a study. So we've got two ways of creating these studies. Or two processes of getting to the same point, essentially. The first one is inside of our 3D model tab. We have a simulation panel available to us for stress analysis. We've also got the ability to go into our environments and access our stress analysis from inside of the environments tab. So either way will get you to the same point, essentially. So I'm just going to use stress analysis from inside here. As soon as I select that, you'll see it takes me now into a new tab, a new contextual tab. Contextual tabs are highlighted in blue, so you can see we've got an analysis tab that pops up over here, and that's specific to our analysis features and tools that are available to us. At the moment, everything is grayed out because we need to actually activate or create a study. So first panel that we've got available to us, we've got the Create Study button. So I'm just going to select Create Study from here. We've got a few different study options that we can choose from. We can choose to apply a static analysis. So that's for anything that we want to apply a single force onto our component and just have a static force essentially applied to it. We've got modal analysis as well. We've got shape generator, which is fairly new. So we've got the ability to create a few different studies inside here. Modal analysis will essentially apply a frequency of movement to your part to see at which point it starts to warp, essentially. For today's study, we're just going to look at static analysis, and if we get some time a little later on, we'll add some modal analysis as well, and just have a quick look to see what we can do within there. We've also got a model tab. So if you wanted to select different iterations or different versions of your model, we can come in and choose those from here. As you can see, I've only got one model state for my model at the moment. It's only the one single component. So I'm just going to use that essentially from here. And once we're happy with that, if we wanted to, oops, shouldn't have hit escape there. Let me hit Create Study again. back to the same options. If we had multiple multiple components or parts inside of our assemblies, we could choose how the contacts were arranged and any conditions we wanted to add to those as well. In this case, it's just, again, the single part inside here. So I'm just going to create it, hit OK, and that creates the study essentially for us. From here, we're essentially going to be working mostly from left to right as we add a few of the components in, a few of the conditions rather in. So you can see we've got essentially in our panel up at the top here, we've got a material panel. Or in our ribbon, we've got a material panel where we can come in and assign materials. We can come in and add constraints, loads. Again, we can come in and apply some conditions to any contacts that might be if you've got multiple components inside of your assembly. And then we've got the ability to mesh our part, and then we're going to simulate the entire process. So generally speaking, as long as you're touching on each of those sections, you'll begin to create the conditions that are required for your component, or for your study rather. What we've also got in the model browser on the left-hand side are a few of those same options essentially in there. So if you know that you want to assign a material, generally you'd want to be able to assign a material so that you know the structural yield and the strength essentially of your material, and that's going to be the basis of your study. You'll want to be adding a material. You need to add constraints. You need to add loads. If there are any contacts, you want to add contacts. Again, we want to mesh our component, but we'll get into that in a bit. And then we got the results at the end of that. So just looking at the interface, they've really made it easy for us to see exactly what's required for the entire process. It will pop up with some more information if you haven't added certain criteria, certain conditions in, and we might see that a little later on as well, depending on if I add everything in as I need to. So the first thing I want to do quickly is assign a material to this part. So if I come into assign over here, you'll see it will allow us to assign a different material to each individual component if we wanted. In this case, again, only got the one part available to me, and this is brake pedal. The original material is the generic material, so it doesn't have a material currently assigned to this individual part. We've got the ability to override that material though, and we can come in and choose one of the materials in Inventor's material library. So if you've got your own material library sorted, you can by all means use one of those materials from inside here. I'm just using Inventor's default material library, and I'm just going to go for a cast iron as my material for this particular part. We've then also got the safety factor that we can come in and choose from. So we can either choose our safety factor to be defined by the yield strength or the ultimate tensile strength. So yeah, when we set in our conditions, we can then say we want to measure our safety factor either by yield strength or ultimate tensile strength. I'm going to use yield strength because I just want to make sure that it's not going beyond the yield of the material itself. If you wanted to add more materials, we've got the materials section over here where we can come in and pick out all of the other materials and add materials to our libraries and so forth. But for this one, I'm just going to keep to the original ones. Nice and simple. Hit OK on there. And we've got that material now assigned inside of the study. If we had any thin bodies, we could come in and add some offsets to them, maybe thicken them a little bit. We've got the ability to come in and add that in here. Again, I don't really have that in this one. I've only got the one, I think I've got two bodies, but one part. The next thing we want to do is make sure that we've got some constraints for the study, and the constraints will ensure that movement is either allowed or disallowed based on particular faces. In this case, we would, with the brake pedal, have a pin in there, obviously, to create that movement. But we would also need to ensure that because we're wanting to create our study of the pin that comes through there where the push rod will be sat on, we need to make sure that once we're pushing into that area, there's a certain face or particular region that then obviously stays still. And for that case, I'm going to use the footrest for for that surface that's going to remain fixed, so that as the pressure is coming from the opposite side, rather than the pressure coming from my brake pedal or the foot part of it, the footrest of the brake pedal will stay still while it's simulating the pressure of the rod pushing up against that pin that's over there. So I'm just going to apply a fixed constraint to that whole surface. We've got the ability to pick an edge or a surface if we wanted to. So I'm just going to pick that face, and I can then apply it. If we wanted further options for that in Inventor, we've got these two arrows here. Whenever there are advanced options available to us, we can come in and add some advanced options, whether we want to use vector components rather. We've got the ability to have that in there as well. I'm just happy with that single face being fixed in position. So I'm going to hit apply on there, and I can OK that, or hit escape, and you can see now it's giving me that visual cue that is sat in place. I'm also going to add in a pin constraint, and I'm going to add the pin constraint into the two surfaces, the two cylindrical surfaces of the part itself. Hit apply and close those off, so that it knows that we're getting pressure from the brake pedal, and we'll have some pressure up at the top where the pin connects our brake pedal to the main bracket of the assembly. Next tab over, we want to be able to apply a force, or a load rather, to our assembly, to our study. We can either, as I've shown over here, we can either apply a single force to a particular face or a particular edge, and quantify that force that's available to it. We can also come in and add pressure. So if you wanted to add a certain pressure to a face as a whole, we've got the ability to add a pressure onto those, and that can be from all sides essentially, that we've got the ability to do that. And if we are working with a uniform load on a circular surface, we've got the ability to add a bearing load as well to a circular surface. In this case, I just want to add a bearing load rather onto the cylinder over here. Actually, it's going to be from one direction, so I'm going to cancel that rather than just add a force instead to this surface from the inside. And then we've got the ability to choose a direction in which we're going to be applying this force. And for this one, I'm just going to choose one of the edges. So to apply direction, we can either choose a face, and it will be normal to the face for our direction. And you can see once I've selected that face down here at the bottom, it's now normal to that particular face. Otherwise, if I select again, I could choose an edge, and it will be along the axes of that edge. So we've got two options inside of Inventor for choosing directions. Generally, it would be a face for a normal and an edge for an aligned. But we can then also flip the direction as well at any point if we wanted to. And then we can now apply a magnitude for this. So if we have a look at the magnitude now, this is in newtons. So roughly, we can probably about, add about 10 times the force, more or less, just to get a nice rounded number. And then looking at it with it being a brake pedal, you're probably only ever going to add about half of the average weight, I suppose, to it. So probably let's go for something like 40 or 400 newtons essentially from there to apply. 40 kilograms sounds a bit much. Let's go for about let's say 200 newtons of force applied to that pin over there. So if I hit apply over there very quickly, you can see that that will now be added in as a force. And if I close off of this window very quickly, you can see we've now got our material, we've got our constraint, and we've got our load assigned to the pin itself. Again, we don't have any contacts. We don't have multiple components in this, so we're not going to assign any contacts. What we do want to do, though, is we want to mesh our model. And essentially what the mesh will allow us to do is, because we're using a process called FEA, Finite Element Analysis, essentially it's going to break down our component into multiple smaller components, each with their own axes and movement, and essentially allow the force to dissipate throughout those individual faces, if you are familiar with that process. But essentially we want to be able to break down our entire component into smaller faces and apply the load and let it spread throughout our part from there. And that's essentially the process we're going to be using for meshing our component over here, and the reasoning essentially behind that. We can come into our mesh settings as well in the mesh tab, where we can give an average element size, we can give a minimum size as well, and then we can give a grading factor and a maximum turning angle that's available to it there. And if we wanted to create curve meshed elements rather than straight meshed elements, we've got the ability to allow that in here as well. So I'm just going to keep to the default settings, but we can adjust these settings if we ever needed to as well. And that's just in the mesh panel. We've got mesh properties or mesh settings available to us then. I'm just going to select default options and say I want to mesh my view. That'll then automatically mesh my entire component for me here. And you can see the regions that are a little bit smaller and have a little bit more or a bit less surface area will be broken down into smaller ones automatically with the settings that I've set there. So it dynamically adjusts the scale of the mesh for me as it gets to areas that it knows will need a bit more finer detailing essentially for us. So now that we've broken down our model into the various meshes that it requires, we should have that done over there. We can now essentially, as you can see, the next option is then to, or the next button in the list is the simulate button. So if I come in and try to simulate this, you can see that my simulation is ready to study. So, or ready to run the study. So I can now hit run and it will go through the process. If I was missing any of the elements, if I was missing any constraints, if I was missing any of the meshing, it would pop up with a message at this point telling me what is missing to finalize the study. So it does run through its own little pre-check beforehand to let you know that everything's ready to run. And as soon as I hit run on here, it will now go into the background and run my study locally. This is a very small part. So it will run this through very quickly, but if you add more surfaces, if you have a finer mesh or a bigger part, it will take a little longer to run through from there. And now that I've run through this, we've got a few views that we can essentially apply to this, to the results of this particular study. The first one is the von Mises stress, and this is the amount of stress that's then applied to each of the individual surfaces, and you can see how the areas with the most stress are highlighted now in red. So these are areas that will probably be beyond their safety factor. If I move off to the side over here, you can see we've got our maximum stress is 1,251 megapascals. So yeah, a lot of stress that's applied to those areas on those particular surfaces. But what we can also do is we can come in and have a look at a few of the other views, which will show us a few other bits of information of the simulation itself and add a bit more detail rather to the simulation itself. So we can come in and have a look at its first principle stress. And you can see with first principle of stress assigned, we've got a lot more stress in the area on the part itself that would be applied with that load that's currently assigned to it. We've got the ability to view the third principle stress as well as the overall displacement of our model. So if that load were to be applied to our part at that particular point, you can see the amount of displacement that will be shown, that will be produced in that. At the moment, this will be adjusted, although by the looks of things, this is only adjusted 1 times. So if I come in and view the actual displacement that will occur in this one, this is adjusted, so it is inflated ever so slightly. If I have a look at the actual, you'll see it's not that much. It is by default, it will show an exaggerated displacement, just so we can kind of see more or less which areas will be affected most by it. Yeah, so you can see it's not that much, but a bit more than what we would want to allow for this particular application of our part. So in our display panel over here, we've got a drop down next to the I think what the name of it is, the displacement display. That's the one. We've got the ability to come in and show greater displacement and actually factorially displace the components themselves. So yeah, we can come in and add more of an exaggerated view, essentially, of the displacement itself, just to get a better understanding of where it is, where the stress or the displacement is taking place for the most part. And that's for any of the views. So if I had to now go to my from Mises stress view, we can see it's also adjusted by 5, so it's 5 times the displacement, or 5 times the maximum, essentially. If I go to the actual, it'll show the actual displacement itself. So yeah, we've got the ability to view those in multiple ways and actually begin to have a deeper look at the entire at the results as a whole. We've also got the ability to have a look based on the safety factor. So you can see on our left-hand side over here, we've got a graph that shows the colorization based on safety factor. So in our red zone is essentially 0.61, so it's below our safety factor. So it's all of those areas that are colored in red have essentially failed our safety factor. We can essentially see anything that's now in orange is 3 times, so that should have survived, and everything in green and blue is more than fine with regards to safety factor. So our weakest points essentially will, as we pretty much assumed from the beginning, will be that the pin itself. And so the way we would want to fix this is then obviously to thicken the pin, but we can't really thicken the pin without thickening the model itself. So if I had to now come in and try to thicken that particular part, I'm going to go to this other part over here that I have ready to thicken. Essentially, what we want to do is thicken the base of the part itself and the pin at the same time. And the way I've got this configured, it's fairly easy to make that fix. So the way I created this portion of the brake pedal itself was just with a shell. So I can come back at any point and edit the shell itself. So if I find the shell in my model browser over here, I'm just going to right click and edit the feature. I want to keep the same thickness on the outside. So it's only really that bottom face that I want to thicken. So I'm going to expand and go to my advanced options in there, and I'm going to come in and add a surface that I want to have a unique thickness on. So in my advanced options, I can come in and use a click to add. I can then come in and select a surface that I want to add to that, which I've just selected that bottom surface, and I can come in and override that to a 1.5 millimeter thickness. So that's a little thicker now than the sides of the part itself. So if I hit OK on there very quickly, you can see we've now got a thicker bottom to our pedal over here. I then also want to thicken the pin itself. So if I select the pin, I believe it was extrusion 5, that's the one there. If I edit the sketch very quickly and edit the diameter of my my pin itself, I'm just going to change that to a 1 mil thickness on the pin, just to make it ever so slightly thicker. Hit finish sketch, now updates the part including the hole, and then creates the pin that's a little bit thicker now as well. So essentially what I can do now to confirm that this has improved my part is I can go into my stress analysis from here. Just just want to see if I had one set up. I didn't, so that's fine. We can go into stress analysis. I did actually have one in here, and this was using pretty much the same loads, same structure essentially. I can come in and just update my contacts, update my mesh, and that should now allow me to run through that study again. So I can come in and hit simulate, run my study, and we should see now that it's a lot stronger than it was before. So just thickening that part, we've got the ability to see that our load is a lot better. You can see it's now even starting to add some stress essentially to the pin itself. But our numbers are way lower than they were with the thinner part. If I had to come into my displacement, you can see my displacement here is at a maximum on the opposite side because I didn't add the pin in over there. That won't help. Let me add another one here very quickly. So let's add another pin to that face over there, apply, and simulate this very quickly again just to confirm. But you can see our stress is a lot lower now. So it's 266.8 megapascals as opposed to if we go to the original part into the study at 1,251. So dramatically smaller. And this is where we can essentially come in and ensure that our parts match certain criteria before we actually go and test our component any further. So the beauty of this is we've got this straight inside of Inventor, and we've got the ability to make use of the study again before we even go to the manufacturing. So if you ever are unsure and wanted to test the strength of your components before going to manufacturing itself, we've got the ability to do that from directly inside of Inventor. Awesome. I hope that's been beneficial for you guys today. I see we are running out of time. Apologies for going a little over what I was expecting to. But yeah, I hope that's been good for you. If there is anything else you ever want to have a look at in a bit more detail, or any suggestions on other videos you'd like to see us do, please feel free to drop a message or a comment or get in contact with us, and we'd be happy to facilitate that. But yeah, other than that, thank you so much for joining us today. Have a great day further. Goodbye.